Alright, we're good.
All right, sick. So, absolute value of force is equal to, and I think a lot of you already went over this, but this is special for Thehan. So, is equal to G M1 if I could write M1 M2 all over R squared. So the big G in this case is the universal gravitational constant, which is equal to 6.67 times 10 to the negative 11th. It is at the very beginning of the AP formula sheet. M1 refers to one of the masses, M2 refers to the other mass, and then R squared is the distance between their centers. Remember, whenever you're dealing with like almost every problem in AP physics, you can treat every object like it's a point particle. So planets are just points. We don't care about the rest of it. And this gives you the attractive force between the two planets. Um, so if I said that the Earth was, Alan, can you give me reasonable numbers this time? Because I know last time I just used arbitrary numbers.
Reasonable numbers. Are you doing like relative to something?
I'm giving need distance and massive moon, massive Earth.
Mass of Earth do, I don't know, 10 to the power of, I think, 10 to the power, no, 10 to the power of 10 kilograms, and then mass of the moon is 10 to the power of 6 kilograms, and then distance is, I'm totally spitballing this, I think it's 10 to the power of, let me look it up real quick.
Just any reasonable number is fine.
Uh,
Wait, so what is it called? The G is the universal what?
Universal gravitational constant.
300,000 kilometers for the orbit.
And does this equation it only finds the attractive force of planets or is it any two
It's any
objects?
two objects.
Any two
Okay.
objects, yep. As long as you know their masses and the distance between them. Obviously, generally you're dealing with planets though, because the gravitational force of your pencil, for example, is next to nothing.
But
Um,
still, you could technically find it.
yeah, it exists. It's there. Everything has a gravitational force on every other object.
Mom has a pretty big gravitational force.
Oh, sorry. So with this problem, we said that the Earth has a mass of 10 to the power of 10 kilograms, and the Moon has a mass of 10 to the 6 kilograms, and they are 300,000 kilometers. Can we do that in meters so I don't have to convert?
Wouldn't it be just 300 million meters?
Yeah, 300 millimeters um, apart.
Also,
So,
I fucked up. I messed up the numbers.
all
It's
right, no,
still,
it's
still a
great.
little low.
300. We're just doing 300,000 meters. We're done. Okay. So, how would we use the equation to find the attractive force between these two planets, or between the Earth and the Moon? Any guesses?
Could you repeat the question? I'm sorry, I didn't hear.
So we have the Earth and the Moon. The Earth has the mass of 10 to the 10 kilograms, and the Moon has the mass of 10 to the 6 kilograms, and they are 300,000 meters apart. How can you find the attractive gravitational force between them?
Can't you use the formula?
Yes. So how would you plug it in?
So it would be G, which is 6.67 times 10 to the whatever times
Mm-hmm.
10 to 10 times 10 to the 6 over what was the radius?
300,000.
300,000 squared.
Okay. And so if you were to solve that out, that would give you the attractive force between these two planets. And so remember that the attractive force is going to be the same for each of them when you're only isolating these two planets. So the Earth is being pulled this way by some force, and the Moon is being pulled this way by the same force. But that doesn't mean that their accelerations are the same because they have different masses, right? If we have the force, how do we get the acceleration induced by that force on an object?
Um, is it like a centripetal acceleration? Like could you
No,
do B squared over
just
R?
there's just a force and a mass. So if you remember back to the very beginning of physics, F is equal to ma. So the force over the mass of the object is equal to the acceleration. So since they have different masses, even though the force on both planets or both bodies is the same, they're going to have different accelerations. Does anyone have any questions about that so far? Okay. And the second part you need to know is about gravity. So that's about, the gravitational force. The next one is gravitational field strength. And gravitational field strength is the same as the acceleration due to gravity. So for example, on the surface of Earth, we all accelerate if we were in free fall at 9.8 meters per second. So the gravitational field strength is 9.8. So let's say we had a planet, Earth, and it was 10 to the 10 kilograms, like we said. And there's something that is 1,000 meters away from the center of Earth. Obviously, these numbers are ridiculous, but just to make it easy, 1,000 meters away from the center of it, and that's falling towards Earth. How could we figure out the acceleration due to gravity of that object? And know that the only mass we have is the mass of Earth. We don't actually have the mass of the object that's falling. So does anyone know how we could figure out the acceleration due to gravity of that object?
Is it where you set the universal gravitational constant equal to the centripetal motion thingy, the mass times velocity squared over r?
So there's this one. This problem doesn't really have any rotational motion in it. It's just falling
Yeah.
straight towards Earth, or whatever planet this is.
Yeah, the thing is that in AP they put gravitation and circular motion together because of orbits, but they're still not the same. And the only time you're ever gonna find them used in the same problem is for that weird problem that you guys got with the loop to loop, and for like orbital problems. But beyond that, you're not gonna really get they're not gonna be used together unless like you can't expect them to be used together basically. So here the solution is uh I don't want to say deceptively simple, but it is deceptively simple.
So kind of building off that, obviously we have this equation, right? But and I'm going to just label this planet as being mass 1, right? Um, so this equation requires mass 1 and mass 2, right? But that gets the force. We only know mass 1, which is the mass of the planet. We don't know the mass of the object. But we don't need force, we need acceleration. So knowing that, how can we possibly make this equation only use the mass of the planet? So just starting with this, if we happen to, let's say we knew everything on this side, right? Oops, that's moving it. Did not mean to do that. All right. So let's
Wait,
say go ahead.
I just have an idea. Well, you're saying that's the force of gravity, right?
Mm-hmm.
But force also equals mass times acceleration, right?
Correct.
So couldn't you just set it so ma equals gravity mass r over r squared, and then you just cancel out the masses?
Yes, that would be correct. So the mass of the object times the acceleration due to gravity is equal to g, the mass of the planet, mass of the object. Sorry, I have to move the board a bit. Mass of the object over the distance squared. And then if you were to divide both sides by m2, it would cancel out. So what you are left with is acceleration, which remember we talked about earlier is the same as gravitational field strength, is equal to g, the mass of the planet, over the distance away, squared. And if you think about it, it makes sense. It doesn't, one of the main things that we talk about in physics is that all objects fall, at least on Earth, all objects fall at 9.8 meters per second squared. There is no, it doesn't matter if it's heavy or light or anything like that. As long as you ignore air resistance, they always fall at 9.8 meters per second squared. So all that matters is the planet that's causing the gravity. The mass of the object doesn't matter. And you can see that through this. When you work it all the way out, the masses cancel out.
All right, so Nathan, I just thought of something. Do you want to talk about Kepler's laws at all? Probably not today, but at some point.
Yo, we talked about those in class.
Like today?
No, like dude, like yesterday. I was there for that.
So
Nah,
yeah,
yeah, it was yesterday.
here's my opinion on that. We can, right? But my opinion on it is I have never seen it required on any of the past AP exams. So
He
what's all the
said
ones that are available? Go
he
ahead.
said it. I think he said something like it's not gonna really be on the test that much.
Yeah,
Yeah.
like, and the thing is if it is, you can almost always, and at least in all of the past AP and IB exams, it's been always, you can always solve it just not using Kepler's
Of course,
equations. You
it
can
takes
solve it
longer,
another way.
but
Right, it does take longer. Like, it can be a time saver if you know it, but it's not required. That's my opinion on it. I've never used it. I've forgotten it, to be honest. So I definitely couldn't do it right now. I'd have to look it up again.
yeah, no,
Um,
there's 3 total, and 2 of them are just confusing.
so,
That's about it.
like,
Yeah,
we could, but my opinion is it's not worth it.
Yeah.
he said something about like if you're in an ellipse, depending on where you
Shit
are,
going in oval.
it takes like the same time.
Yeah, no. So
But
the thing
it's
is that
that
that law I think is the second law, and it's if you imagine like the ellipse as an area, an ellipse has 2 foci, which are basically like it's like the center, like the very center of a circle. If you just stretch it out, uh, it's weird, but like if you were to imagine the area drawn by the object moving a certain distance in a certain amount of time, like making a triangle pointing towards the center, that area of that triangle will be the same regardless where the object is in that same amount of time. It's like impossible to explain without showing you something, and we have something else we need to do today anyways. So we'll probably do that
it's
at some
alright. Don't
point.
worry. He already showed us in class.
All right, well that's
Yeah.
good then.
And like I explained, my opinion is it's not worth it.
Yeah.
But if it's gonna be something like that he puts on his tests, for example, we can go over it. But as far as AP and IB, unless you're mastered everything else, I don't think it's worth it.
And
No.
Right? If you are, then go for it. I mean,
it's 55, Nathan.
all right. So is everyone here AP or do we have IB people? I think everyone here is AP.
I think so, yeah.
All right. Rip.
Bro, my calc teacher called me. Sorry.
All right.
Nice. All right. So let's talk about FRQs for a second. So has anyone here taken an AP test with FRQs before? What am I saying? Everyone here has. Because y'all taken
Nope.
World.
No, none of
Um,
us have.
You
No.
forgot about
We're all
all
freshmen.
we did
Oh.
was modified DBQ, my guy.
Yeah.
Right.
I got
Okay,
7
well,
points.
so is that none of you or is that some of you?
No, none of
It
us. None of
should
us.
be none of
Had an
us.
FRQ.
I literally have 5 AP exams this year, and I haven't taken a single AP test in my life.
God, that sucks. All right, well, so this is going to be
Unfortunate.
useful to all of the FRQs, and particularly the ones that are science-based, but there's something called command terms. I put them in notes resources yesterday. And command terms are the way that they word the question to ask for a specific thing. In AP, there are 8 of them. In IB, there are 53. So, luckily, like I said, we only have AP people today, so I only have to talk about the AP ones. But it is very important to understand what they mean, because if the question asks you to derive and you calculate instead, you will get a solid 0. So is everyone able to find the command terms document in notes resources? Or is there a better question? Was anyone who wasn't able to find it? Okay, cool. So just look at that, read through it. Like I said, AP is not that bad because there's only 8, and most of them are pretty self-explanatory. The other part is whenever you're doing FRQs, always remember to, especially on questions that are like derive, use the right variable names. If they give you variable names in the problem, use those. If they don't, or if they only give you some, use ones that make sense.
And make sure to
Right?
define them. Make
Mhm.
sure to specify which one is which.
Yep. And also try to avoid using variable names that are the same as units. Like don't use n for normal force because that could also mean newtons, right? So you can do Fn, but don't just do n. Technically, that's not going to eat points up, but it can be confusing. And so again, for AP, rounding doesn't really matter that much. Just pick rounding that makes sense or significant digits that make sense, and you'll most likely be correct. Whenever we have anyone on IB that's completely different, IB is super specific about that. You can get the entire question wrong if you don't do the right number of decimal points. But for AP, just kind of pick things that make sense.
Yeah.
let me see. Is there anything I'm missing, Ellen, about FRQs?
Uh, other than just make sure to pay attention to the command terms. Not really.
Okay. So, in the future when we do other FRQs, they will actually be related to what we're learning at the time. With the first one, we're not doing that. We're just doing a fairly easy one. That is, well, I won't say what it is, but this one it shouldn't be, in my opinion, it's not that hard. However, because none of you have done any FRQs for any AP exams ever, it may be kind of hard. So I apologize in advance. But especially considering that he's not really doing FRQs in class, this is definitely going to help. Free response question, by the way, is what that is. It's what FRQ stands for.
Yeah.
But considering he's not really done these style of questions on his tests, this is going to help. So with that said, as for responding, so the way we're going to do this is I'm going to give it to you. You'll see. It's like solving, but they're gonna ask for like explanations and like more words and just like a more deep understanding than just trying to get to a number is essentially what an FRQ is. So the way we're gonna do this is I'm gonna give it to you in a second. We said 30 minutes, which should in theory be more than enough time to do it. And then you're going to DM it back to us. And then we will grade it by the next one and give you direct feedback. As for responding to it, if you have a printer and you can use it, I would print it out because several of the questions involve drawing. Or if you have like a tablet you can draw on, that works too. Second to that is on a separate sheet of paper. Third to that, which I don't recommend, is typing it. I would avoid typing it because, like, especially derivation and drawing questions are going to be not fun. So yeah, are there any questions?
Wait, when you say derivation, like deriving something, is it like calculus deriving or like
It
just
is
finding
on
something?
your command term sheet, and that will be
Oh,
the
Yep.
okay.
exact thing that AP is expecting.
Yep. I mean, and just to give a specific answer, and this is coming directly from that sheet, you have to start with equations that are on your formula sheet. Those are the only equations you can start with. And then you go from there, like you manipulate those equations or combine them, solve them, whatever, to get to your final answer. You cannot start with any other equations that are not on your formula sheet. Which again is also why I think calculus loss is, not enjoyable to learn because it's not even on the formula sheet. You can't use it in derivations.
So I wasn't, or I don't think I was here because my teacher called. What's the command sheet?
If you go in notes resources and go up to
Oh, okay.
yesterday, click on the AP one.
Thank you.
Okay.
Do we have to like have this done like do we gotta do it like right now?
What's
So
the plan?
that is the plan because it's going to be timed just like on the test. And it's only going to take 30 minutes. So unless you have something else to do, it's only going to be 30 minutes of your time. If you really have something else to do and you would rather do it later, that's fine. But we'd much prefer it if you do it in the next 30 minutes as soon as we give it to you. I truthfully, if you understand the concept, it shouldn't take 30 minutes.
Yeah, because their recommended time for these, I think, is, what was it, 20, 25 minutes?
Yeah, this one, their recommended time is 20 minutes.
Yeah.
But again, since you guys have never done FRQs for any AP exams, more time. Are there any questions about? And you can ask questions about FRQs as soon as we give it to you. That's fine. Although just nothing about the question itself. But are there any questions about FRQs in general right now? All right.
I'm
Cool.
gonna stop the recording because this is at this point just gonna be pretty much just working. Not gonna be too much to
Okay.
show.